All right, so hi everyone, welcome back to yet another lecture in mathematical methods. Okay, uh, we're getting to the end, so bear with me. What we're going to do today is we're going to look at something that we wanted to do initially when we started looking at sample means. All right, so if you remember, our initial aim as the music creators we were was to find out something about all of the songs on the platform. What was that accent there? All of the songs on the platform, right? So we wanted to know something about the population. The case was same with what was it? Yeah, the cans. Okay, the drinks. The case was the same. We wanted to know something about the entire population of the cans that are being created. Okay, so that is what we're going to do it now. Okay, so say you do some samplings, you get some bunch of values, you get this. Okay, sorry, not x. So you get that your sample mean is 10. Okay, and your standard deviation of the population, I know, just bear with me for a second, is 2, and your sample size, I don't know, is 20 or whatever. Okay, so now you can use this information that you've got from your sampling to say something about the population. How do you do that? You use confidence intervals. Right, now what is that? Where the hell did that come from? That's going to come in there. Okay, so what is a confidence interval? Well, it's an interval, okay? It is used to predict something that you're trying to, well, predict. You're trying to show something using your data, and then that's where this comes in. So in our case, because we're looking at, for example, the mean of the population, all right? In our case, it's the mean of the population that we are trying to estimate, okay? So the interval is going to be a range of values that, and we're going to say that based on our data, based on our sampling, we are saying that the population mean lies in this value, in this range. Okay, so that is what the confidence interval really represents, and what it is. How to get this confidence interval is like this. So this is your mu, which is the population mean, is given by x bar plus z times sigma over square root n. Okay, what is z? I'll get to that in a second. And it is greater than x bar take z times square root of n. Oh, sorry, z times sigma over square root of n. Okay, so here's what we got here. Well, the gaps look a bit funky, so I'll fix that up a little. We got this, and this. A bit better. All right, so here is your stuff, okay? This is your population mean, sample mean, population standard deviation, sample size, okay? Now, before I move on to other stuff, I just said population standard deviation, right? So to guess the mean, you need to be able to know the population standard deviation, right? But what if you don't? Excuse me? What if you don't? Okay, what if you don't know the standard deviation? What can you do in that case? Well, you can just use the sample standard deviation, okay? But when to use what, I know it can be a bit confusing, but if you have the population standard deviation, you use that. Otherwise, you use the sample standard deviation, and that is kind of all there is to it. But it is a bit more intuitive after you have done a few questions. So please do that. We will look at some in the exercise part as well. So please pay attention to that. Okay, so now coming back to our other variables. Now, here's where the confidence part of the confidence interval comes in. Okay, so I'm going to go away for a little bit, all right, and I'm going to look at a simple range. Okay, I am saying that I have a range based on my sampling, and I am saying that the mean lands in this range. Right, so I'm saying that the mean is in this range, okay, but the mean is a continuous variable, all right, it has an infinite number of values, so there's a chance that the mean is not there, the mean is outside, okay, there's a chance. So what we can do is we can make our range bigger, okay, and then the mean is in there. So my point is that as your range gets bigger, you cover more values, so it's more likely that the mean you are trying to find is in that range, okay? So the bigger your range, the more likely that the true mean is in that range, okay? and that width is what we call the confidence, okay? So obviously, the greater it is, greater the width is, the greater the range is, the greater the chance of getting the mean. That means you're more confident that the true mean lies in your range. That's where the confidence part comes in. And the Z here, that's what it does. It controls the confidence. Okay, how does it do that? It does it by doing what we did. It controls the width. Okay, so it controls the confidence by increasing or decreasing the width. Obviously, you would see that if Z gets bigger and bigger, the values of the max and the values of the min get bigger and smaller respectively, so the range gets bigger. Okay, that's how Z controls it. Now, what we say is, for example, if you want a 95% confidence, which means that you're 95% confident that the true mean lies in your given range, or another way of saying it is that you do this process and 95% of the time, the true mean will lie in your given range, okay? But either one works. I personally prefer saying that we are 95% confident that the true mean lies in a given range, okay? When that is the case, Z is equal to 1.96, okay? And for example, if you want to be 68% confident, that's not very good, but Z equals 1, okay? Approximately Z equals 1. So you can see how Z changes, and as the confidence gets bigger and bigger, Z gets bigger and bigger. As the confidence gets smaller and smaller, Z gets smaller and smaller. Important thing to note before we move on to other stuff is that because the population mean is a continuous variable, it can take on an infinite number of values, okay? Therefore, to be 100% sure that your range contains the value, you have to look at infinite number of values. Therefore, the width has to be infinitely big, okay, to make sure that you have the value. So if to be 100% confident, width has to be infinity, okay? Let's just putting that out there. It's a common question, so just remember that, okay? The last thing I want to talk about is something else that controls the width. It is this n here, okay? So if you look at this part of the equation, so let's say you have an x bar as the ones we described before, 10. Let's say I just want to use a 68% confidence interval, so Z becomes 1, sigma is 2. Let's say your n is 16, just so that the square root is easier. So the max value of this range is then 10.5, okay? Now imagine I increase the sample size to, 100. What does the max value become now? It becomes 2.02, okay? So you can see that as the sample size increases, the max value gets smaller and smaller. Same thing happened here. As your n gets bigger, you're subtracting a smaller number, so your minimum gets higher and higher. So your range starts to close in, the gap starts to close in, so your range gets smaller, the width decreases. So these are the two things that control it. And the take-home message, this is your formula. This is how you predict what the population mean is. The more confident you are, the greater your Z value is, the greater the width. The more the sample size, the smaller the width, okay? And you can do that whilst keeping your confidence the same, okay? So it kind of counteracts against it. Again, and this again drives home the point that the bigger your sample size, the more accurate you are, okay? And that is all there is for this part of the lecture. Hopefully the next one will be the last one, and we're gonna, end it there.